All right, so the calculation for the F-test statistic is a little bit complicated. It's not hard, it's just a little bit time consuming. So I do want to walk through one example of how this is calculated, and I have it all typed up for you, just so you can understand kind of at least a little bit about where this is coming from. So we talked earlier about those degrees of freedom and how there was a degrees of freedom associated with the numerator and a degrees of freedom associated with the denominator. And that's related to, when we get to the final step, how to calculate this F-test statistic, where we have this fraction here that we're calculating. So we're going to start by looking at how to calculate this numerator. Okay, so we're going to measure the variation among the sample means by a weighted average of their squared deviations about the mean X bar. And this mean X bar that we're referring to here is the one for all the sample data. So if we pile all the sample data together and find the average, that's what we're talking about there. These other X bars that have these little numbers next to them, each one of those represents the mean of a sample from the specific population. Okay. And so MSTR is the treatment mean square. So that's what we're solving for here. SSTR is the treatment sum of squares. And then K is the number of populations that we're sampling. All right, so here's our formula for this treatment sum of squares. You take the sample size, and then you're going to multiply it by the mean of that first population minus the overall mean, and then square that thing. And you'll do that for each one of your populations. So let's take a look at what that is, because that's just a lot of letters all jumbled together. So let's look at this example here. So this is on energy consumption, and what we're interested in is whether that average consumption is the same, whether people live in the Northwest, Midwest, the South, or the West in the US. So I have some data points that are pulled here. I actually also have my sample mean for each one. My X bar, my overall mean, I would need to take all of these numbers here and add them all up, and then divide by 20, which is my overall sample size. So that gives me 11.9. And then to get this treatment mean square, I'll take that first sample size. There's 5 pieces of data here, and the mean is 13. And I'll subtract off this overall mean, 11.9, and square it. And I'll do that for the Midwest, for the South, and for the West. And you end up with about 32.5. So once you divide that by that 4 minus 1, or the 3. So that'll give us the numerator for our F statistic. Let's look at how we find the denominator. So to find the denominator, we're considering the measure of variation within the samples. So this is a pooled estimate of the common population variance, sigma squared. So remember that sigma is the population standard deviation, and whenever you square a standard deviation, you get the variance. Okay. So we're going to look for the mean square error, and we're going to take the sum of squares of the errors and divide it by n minus k. So this formula is a little bit different. So we have the first sample size minus 1. And then that's going to be multiplied by the first standard deviation squared, okay, or the variance. And then we'll do that for the second population. So we'll take the second population sample size, subtract 1, multiply it by that one standard deviation squared. So we'll do that for all of them and divide by n minus k. And so I've done that for you here with this electricity example. So that first sample size was 5, and so that formula is 5, take away 1. And the standard deviation for that, I went and found that already, was 1.87. So these guys all lined up here, then we're adding all of these up. And I get 5.144 for the total for the denominator. So now I just need to divide these two results that we have here to get my F statistic. So that ratio of variation among the sample means to the variation within the samples is given by this formula. Large values of F indicate the variation among the sample means is large relative to the variation within the samples, and hence we would reject the null hypothesis. So our null hypothesis is going to be that these means are all equal, right? There's nothing interesting going on, everything's status quo. To reject the null hypothesis would be to say that these means are not all equal, that at least two of them are different. So I have made that calculation down here, 6.32. So this is how we calculate the F statistic. You will not be calculating this by hand. You will be using Excel. We're going to look at how to do that in Excel in just a little bit.